Alright, so let's talk about the circumcenter of a triangle. And the circumcenter is the center of a circle that circumscribes a triangle. And let's draw a circle first. Uh, Probably a good idea. And then discuss from there. So let's say this is a circle, and I'll draw any random triangle that's inscribed in this circle. And I hope this is good enough. Let me just draw it a bit differently. So this one's fine. This is the second side. And this is the third side. So let me just name these vertices A, B, C. Let their coordinates be x3, y3, x2, y2, and A, B, x1, y1. And let's say the center of the circle, of this circumcircle, let's say that the center is O, and that O lies somewhere here. Alright. O lies somewhere here. Now we want to figure out what the coordinates of the center are, given the coordinates of these three vertices. And let's just continue on with it. Let's just think how we can do that. So with triangle centers, as we have seen, the best way is to write something in form so that we can apply the section formula, and we need ratios for applying the section formula. So since the circumcenter is constructed by using perpendicular bisectors, and those perpendicular bisectors themselves don't just originate from a same point, and they don't show that sort of symmetry, what we do is we first connect the circumcenter with the three vertices. So this is the first one, and let me just extend it further as well. So OA, let's say, or let me just draw it a bit better this time. Alright, so OA intersects BC at the point D, and let me also join OB. I don't think so. I need to extend it all to the other side. Let me just do that anyways. And let's also join OC. First of all, just a point of observation, OA, OB, and OC they're all equal, since it's just the distance from the center to any point on the circumference. And yeah, now we try to figure out what the coordinates of D are, and then we try to figure out the ratio of OA is to OD, and then we write the coordinates of the point O itself. So how do we write the ratio BD is to DC? This is the first challenge. Let's think about it. With the incenter, we had the angle bisector theorem. With orthocenter, we can use the perpendicular distances. What we can use here is a really nice property of circles, and that property is the fact that any angle that's formed on the center and that subtends another angle on the circumference is going to be double that. So this angle is the angle A, then this angle should be 2 times the angle A. And similarly, this angle would be 2 times the angle B, and this will be 2 times the angle C. Now what do we do? So we need to write BD is to DC. We need to find this ratio. So BD divided by DC is equal to, if you notice carefully, BD and DC are both parts of triangles that are formed within ABC. So BD over DC, why not we write this as the area of triangle ABD divided by the area of triangle ACD. Since both of these triangles have the same height, the ratio of the bases is equal to the ratio of the areas. How do we write this? Well, ABD divided by ACD, how we can write this? Let's think about it. We can write this as the area of triangle ABO, or triangle AOB to be a bit better, divided by plus the area of triangle BOD, that's ABD, divided by the area of triangle AOC plus the area of triangle COD. Does this lead us to anywhere? Well, first of all, we do know that 2C and 2B are the included angles in triangles AOB and AOC, but what about BOD and COD? We don't know exactly we can't exactly find these angles in a simple enough manner. All right, let's think from a different angle now. We need to figure out what BD over DC is. These were the first two triangles that came to our mind. But there are two more triangles in which BD and DC are. So BD and DC are a part of triangle OBC. So you can write this as the area of triangle BOD divided by the area of triangle DOC. Again, the heights of both of these triangles are the same, so the ratio of the areas is equal to the ratio of the sides themselves, of the bases. So you have area of triangle BOD here, you have it here in the numerator. You have the area of triangle DOC here, you have it here in the denominator again. And we know from basic arithmetic that when AB is equal to CD, C over D, you can write this, both of these are going to be same as C minus A over D minus B. So we just do that. So we write this as this entire numerator minus area of triangle BOD. So that just leaves us with area of triangle AOB divided by the area of the entire denominator minus area of DOC. So that gives us triangle AOC. And what else? We can write the area of triangle AOB as half times, I think I should use a darker color. So half times OA times OB times the included angle, so that's the sine of 2C, divided by half of AOC will give you OA OC sine of 2B. Now halves will get cancelled out, OA will get cancelled out, and OB and OC are the same. That's the first point that we noted, since it's just the radius of the circle. So the ratio in which D divides BC is D divides BC in the ratio sine of 2C is to sine of 2B. So that's the first breakthrough that we make in this problem. So we can write the coordinates of point D. The coordinates of point D are going to be sine of 2C gets multiplied by x3. So x3 sine of 2C plus x2 sine of 2B divided by sine of 2B plus sine of 2C. And similarly, the y-coordinate, let me make some more space. The y-coordinate is going to be y2 sine of 2B plus y3 sine of 2C divided by sine of 2B plus sine of 2C. So we figured out what D is. Now we need to figure out what is the ratio in which O divides AD. So what is the ratio OA is to OD? How do we write that? Now, if you think about it, it's the same problem all over again. OA and OD are parts of the triangle. First, there are two triangles that you can use. The first one is ABD. That's the first triangle. So you can use triangle ABD. And the second triangle that we can use, similar to what we did it here, the second triangle that we can use is ACD. Triangle ACD. So in triangle ABD, OA over OD is equal to the areas of triangle AOB divided by BOD. Alright, so OA over OD is equal to the area of Corresponding to OA, you have the triangle AOB. AOB. And corresponding to OD, you have the triangle BOD. The area of the triangle BOD. And now we use the triangle ACD. With ACD, you will write corresponding to OA, now you have the triangle AOC. So the area of the triangle AOC divided by the area of the triangle COD. Now, we again use a similar arithmetic formula. Now, instead of minuses, you can do plus as well. So you add both of these. You add the denominators and the numerators separately. So the area of triangle AOB plus the area of triangle AOC, you write that right here. So AOB plus area of AOC divided by the area of triangle BOD plus the area of triangle COD. The areas of triangle BOD plus COD, that gives us the area of triangle BOC combined. So this is equal to the area of AOB plus the area of AOC, so COA, potatoes, and the area of triangle BOC. We now use the similar formula, half into the product of two sides into the sine of the included angle. So this gives us half times, let me use white color. We have been using yellow all over the place. This one. So this ratio is going to be equal to half times OA, if we have AOB. So OB into OA into the sine of angle 2C. So OB into OA into the sine of angle 2C. And similarly, in the case of the area of triangle AOC, you have half into OA into OC into the triangle of 2B. And in the denominator, you have half into OB into OC into sine of angle 2A. You have two radii being multiplied together, and all of these are same. Half is same, so we cancel all of these out. And the ratio that O divides AD in the ratio, what's the ratio? So OA upon OD, that ratio is going to be equal to sine of 2b plus sine of 2c. This is to sine of 2a. And notice that we have the same thing in the denominators here, so that's perfect. So we just need to apply the section formula once more, and then we'll have the coordinates of the circumcenter. So O is now going to be equal to the x-coordinate, the second x-coordinate in this case is the x-coordinate of D, and that is going to be multiplied by the first part of the ratio. So sine of 2b plus 2c, this is multiplied by x2 sine of 2b plus x3 sine of 2c divided by sine of 2b plus sine of 2c plus sine of 2a into x1. This entire thing divided by the sum of both the first and the second part of the ratio. So sine of 2b plus sine of 2c plus sine of 2a. And you write the same thing for the y as well. So I'll just write capital Y right here. I'm not going to write the same thing again. And you cancel these out, and you get a nice symmetric expression. x1 into sine of 2a plus x2 into sine of 2b and x3 into sine of 2c divided by sine of 2a plus sine of 2b plus sine of 2c, and the similar thing for the y coordinate as well. So do we have some space here? Let's just write it right now. The coordinates of the circumcenter given these notations is going to be equal to x1 sine of 2a plus x2 sine of 2b plus x3 sine of 2c divided by sine of 2a plus sine of 2b plus sine of 2c. And the same thing again for y. Instead of the x's, you write the y's. And yeah, that's the circumcenter. See you in the next video.